Hello. This Explain It is going to be about writing and completing double replacement reactions. Remember that in double replacement reactions we have everything is in a pair. So we have AB plus CD. Those are two pairs. And what's going to happen is the pairs are going to split down the middle. And the way I remember this is the outsides go together and the insides go together. So on the other side, you put A with D, and then the insides B with C. Now remember, we list the metal first, and then the non-metal, or the plus is the first one, the minus is the second one. So same on the second term, the plus is the first one, minus is the second one. So you always have to combine a plus and a minus and write them in that order. So as an example, let's look at silver nitrate plus sodium chloride. So remember that they're going to split down the middle. The outsides are going to go together, AgCl, and the insides go together. Remember to write the positive first, so you get NaNO3. Now remember, on each case you have to use the crisscross rule to complete the formula. So Ag is a +1, Cl is a -1, you get AgCl. Na is a +1, NO3 is a -1, and so you get NaNO3. You have to remember that this is just a prediction. And in our prediction, we have to determine if this is going to occur or not. And in order to make that prediction, we're going to have to use something called solubility rules. So in the next slide, we're going to talk about using the solubility rules to predict if the double replacement reaction is going to occur. And to do that, we're going to look for two things. We're going to look for the formation of a precipitate or the formation of water. Turn your yellow paper over to the back and look towards the bottom, and you will see the double replacement reactions solubility rules. So we're going to look at these right here. So in our example, what we had was we took AgNO3 and we put it with NaCl, and we predicted that Ag would go with Cl and Na would go with NO3. Now the only way these things are going to work is if one of these is a precipitate. And it will be a precipitate if it is not soluble. So we're looking for one of these compounds to be not soluble. So we look at the table under the solubility rules right here. So I'm looking for something about a chloride or a nitrate. And these solubility rules kind of go by their last names, chlorides, nitrates. So I'm going to look up something about chlorides. I see number 3. All bromides, chlorides, and iodides are soluble except lead, mercury, 1, and silver. Well, look at that. We have silver chloride. So this is not soluble. This is not soluble. That means it's going to be the precipitate. So it's going to be the precipitate. Now if you look at NaNO3 nitrates, I skim down and I see number 2. Number 2 says all acetates, chlorates, and perchlorates and nitrates are soluble. Are soluble. That means it's going to dissolve. So we won't see that. It'll be in the solution. But we will see AgCl. So what I want you to do on your paper is to circle the precipitate. So if you get a precipitate, then it's an indication that this reaction is going to occur. If it turns out that both of these are soluble, then you would predict that it would be NR, no reaction. So let's look at some like that. You should have this worksheet. Hopefully the sub will pass this out to you. And I'll do a few of these with you, and then I would like you to finish this worksheet and then go on and do the pre-lab for Monday's lab. All right, step 1. Write the equations and go ahead and do the double replacement. So we have aluminum iodide. So we get AlI3 using the crisscross rule plus mercury 2 chloride, so HgCl2. That's what I have as the reactants. Now I'm going to predict the products. Remember how this works. You split them up. The outsides go together. So we get AlCl3 plus the insides go together. Hg, and then I do the crisscross rule, and you'll get I2. Next, we need to look on the rules for solubility. Find your yellow paper, find the solubility rules, and let's find the one about chlorides. That would be number 3. All bromides, chlorides, and iodides are soluble except lead, mercury 1, and silver. Well, I have aluminum chloride, so this is soluble. So it will not produce a precipitate. It's going to go and make a clear solution. Now let's look at mercury iodide. So we're going to find the one for iodides. It's the same one, number 3. All bromides, chlorides, and iodides are soluble except lead, mercury 1, and silver. Well, we have mercury 2, so it is soluble. So this one is soluble, this one is soluble, so therefore we would get no reaction. So for this equation, you would end up writing NR, no reaction. So we're going to put here NR, no reaction. And we're done. We move on to the next one. All right, let's take a look at the next one. We have silver nitrate. So we use the crisscross rule to write silver nitrate, AgNO3. They are both 1, so you crisscross the 1s, plus potassium phosphate, K, and then phosphate, PO4, and it's a -3, so I have to put a 3 here. And on the other side, we are going to get the outsides go together, so silver phosphate, AgPO4. Use the crisscross rule, so you'll get a 3 right here, plus the insides, KNO3. They are both 1s, and so using the crisscross rule, you get KNO3. All right, I'll wait a second so you get all that written down. All right, next, get your rules for solubility from your yellow paper, and we're going to look up, by their last names, phosphates. So I see it's in number 5. The borates, carbonates, chromates, oxides, phosphates, silicates, and sulfites are insoluble except those of ammonium and group 1. Is silver in group 1? No. So this is not soluble. So this will form a precipitate. So you circle it. It's going to form a precipitate. Now let's check the other one. I'm totally guessing this one is soluble because once you have one precipitate, the other one remains soluble. So let's check it out. We're looking for nitrates. That is rule number 2. All acetates, chlorates, perchlorates, and nitrates are soluble. So that will remain in solution. Silver phosphate will come out as a precipitate. All right, lastly, we have to balance this equation. So let's see, 1Ag, 3Ag, so I'm guessing there's a 3 over here. Then we go to NO3s, 1 NO3 and then 1 NO3 on the other side. We're fine. 3 Ks, we need a 3 over here. Uh-oh, that messed up my NO3s. Oh, never mind, I made a mistake. There are 3 NO3s. Last, we look at PO4, 1 PO4 on this side and a PO4 on the other side. I think I'm finished, but let me check. 3 Ags on the left, 3 Ags on the right. 3 NO3s on the left, 3 NO3s on the right. 3 Ks on the left, 3 Ks on the right. 1 PO4 on the left, 1 PO4 on the right. It is now balanced. All right, so let me refresh what we did. Step 1, write the equations for the reactants. So we wrote this equation and this equation using the crisscross rule. Step 2, split them apart and put the insides together and the outsides together. So we wrote AgPO4, use the crisscross rule to get the 3. Then we put the insides together, we get KNO3 using the crisscross rule. They are both 1s. Lastly, we use the solubility rules to see if we get a precipitate. Remember, we're looking for a precipitate or water formed. Either one of those will indicate that the reaction occurs. We found that in rule number 5, it said silver phosphate is insoluble. If it's insoluble, that means that it cannot make, or it will not remain in solution. It will make a precipitate. And then KNO3 is soluble, so it will remain in solution. All right, you go ahead and try the rest. I'll check your answers when we get back, when I get back on Monday. When you are finished with the practice worksheet, you are going to work on your lab, pre-lab. This is in your lab manual, so locate this paper in your lab manual. And you are going to work with a partner. One partner does part A and the other partner does set B. You are going to write the double replacement reactions for your chart. So for instance, if you are going to use this block, you are going to, on your own piece of paper, let me say that again, on your own piece of paper, you are going to write the equation for BaCl2 plus AgNO3. Then go ahead and do the split, rearrange them on the other side, and check for precipitates. You are going to circle the precipitate if it is available. If there are no precipitates, you're going to write NR. Remember that we have a lab on Monday, so dress appropriately, and we are actually going to go into the lab and test all of these equations that you have predicted. So again, one partner does A, the other partner does B, and then you copy from each other. Yeah, I said that right. You can go ahead and copy from each other. One person does A, the other does B, and then swap so that you have a piece of paper, a separate sheet of paper, that has all of the equations on there. All right, have a good day. I'll see you on Monday.